Our session or our lecture or our workshop. This introduction, it is workshop. These abbreviations of workshop 1. Workshop 1 is what? Introductions of electronics, schematic symbols. So I was explaining to you the general concept that we are using in technical electronics or in engineering electronics or in electronics engineering. This is very important because I want to show you what the application of the topic that you are going to learn and why should we learn it. Students, local students, I ask you to be serious. I'm serious when I'm teaching. I want your students to sit as a serious student and concentrate. Because when I will be asking you a question in exam, you will find that the questions are difficult. While you are self doing the class, you don't concentrate, you don't pay attention. Are we together? Yes. So let me just review quickly about what I've written here. This is the algorithm. Say algorithm. These are the procedures that we follow in case we want to solve a particular real-life engineering problem. So we say that first of all, we have to identify engineering problems. That's what I told you to state the problems found in W15.4. So this we call the identification of what? Of the problem. Once we identify the problems, then we sit down and think about the ideal solution or the proper solution for that problem. So then we come to the next step that we have to think and explain about proposed what? Say proposed solution. Say proposed solution. Why do we call it proposed solution? Because you are proposing. You are not sure that if the solution that you are proposing will solve a problem or will not solve a problem. Okay, so once it solves the problems, then we change the name from proposed and the name become as the solutions of the particular real-life engineering problem. Are we together? Are we together? Yes. Then the next step, so the proposed solution, mainly we used to present in terms of objectives, such as main objective and the specific objectives in case of the project level. But proposed solutions in case of research, we write something we call it a hypothesis. We formulate the hypothesis. Then the next step, once we have the proposed solution, now we convey it or we represent our proposed solution in terms of diagram. And the fundamental diagram, we call it a general purpose block diagram. So the general purpose block diagrams, this is the high architecture, where that I have to break the whole proposed system into small parts. Into small. If it is a general block diagram for the engineering purpose, you might find that it should have at least 4 parts. Okay? And that's what we used to call it. We can have 4 blocks general that I told you. Power supply unit, input unit, control unit, and output unit. So that is general. So then, once we have our general block diagrams, we use the rectangles and arrows to draw the block diagram. Those are the symbols that we are using. Are we together? Are we together? Yes. Arrows to show the directions of the flow of electric signal. Blocks to show the subsystem or the unit. Okay? So if that's the case, then we open the general block diagrams and we come up with a detailed block diagram. We are also using rectangles and arrows. So for the detailed block diagrams, it has specific information according to the problem that being solved. Detailed block diagrams, then we have rectangles and arrows. Okay? We are using rectangles and arrows. So when you say rectangles and arrows, for example, if this is the input unit, you just write this is temperature sensor. So this block now is more detailed. Rather than the block where we have written that input unit. Are we together? Yes. Are we together? Yes. That's the point that you have to remember. This is general block. This is a detailed block. Okay? Then once we have the detailed block diagrams, we can open each block and come up with a schematic circuit diagram. Screen. Schematic circuit diagram. So the schematic circuit diagrams, we are using schematic symbols of electronic what? Say schematic symbols of electronic components.
Schematic symbols of electronic components.
Again.
Schematic symbols of electronic.
Again.
Schematic symbols of electronic components.
So that's why we have to learn different electronic schematic symbols, because they will help us to draw different schematic circuit diagram. For instance, the test one might be challenging for you. Why? Because you have a lack knowledge of the electronic symbols. You might know that the proper component here or the proper modules here is temperature sensor, but you don't know its symbol. So you cannot represent it in a schematic circuit diagram. You might say that, okay, here it's electric fan. One thing that which I realized, even you don't know how, we don't know the symbol for electric fan. So rather than writing or drawing the symbol of electric fan, you are writing just this propeller, this one. So you find that the students in the schematic symbol, he or she is drawing this one. Are we together? Yes, is it true or is not true? So from there I realized that these people, they don't have knowledge of schematic what? Are we together?
Yes.
We have millions of electronic schematic symbols in electronics. I don't have, or we don't have enough time to learn a lot of them, but I'll try my level best to teach you the fundamental and the detail or the different schematic symbols of different electronic components. Are we together?
Yes.
Are you ready for that?
Yes.
Are you ready for that?
Yes.
Okay. So let us come to question number 1. What is schematic, or what is electronics schematic? What is electronic schematic symbol? What is electronic schematic symbol? Ask your neighbor. What's electronic schematic symbol? Ask your neighbor loudly. What's electronic schematic symbol?
What is electronic schematic symbol?
Schematic. What is schematic symbol? Ask it again.
What is electronic schematic symbol?
So listen the answer from your neighbor. Ask him or her. I am hearing. I want to listen to your answer. Okay. So there are different ways that we can define this terminology. We say that an electronic schematic symbol, an electronic schematic symbol, we say that if there is a pictogram, is a pictogram used. So this is the pictogram used to represent various electrical and electronics devices. Various electrical and electronics devices or devices such as wires, such as batteries, such as resistors, such as transistors, in a schematic diagram of electrical or electronics or electronics circuit or electronics circuit. Stop writing. Remember that I taught you, and I'd like to repeat to teach you, or just to tell you, or to teach you, it's not necessary for your level as ordinary or as a basic technician to claim the definition. Whenever you find any definition, try your level best to extract keywords and then use your own words to combine those keywords to present the meaning of that terminology. I say stop writing, stop copying. For this definition, for the first definition, we say an electronic schematic symbol is a pictogram. Say pictogram. Pictogram. Say pictogram. Pictogram. Say pictogram. Pictogram. So this pictograms is used to represent various electrical and electronics devices such as wires, batteries, resistors, transistors, where in a schematic circuit or a schematic circuit diagram or schematic diagram of what? Of electrical or electronics. So we say it is pictogram. Simply we say that it's a pictorial representation of the physical electronics components or electrical components in the schematic circuit diagram. Are we together? Can I repeat? Pictogram means it's a pictorial representation. When you say pictorial representation, it means that we say that it's a way that is representing a particular component without observing its physical appearance, but we just observe its operation. What does it mean? For instance, the physical appearance of resistor, most resistor is cylinder. It's cylinder, the physical appearance of resistor. The physical appearance of resistor is what? Is cylinder. It's the physical appearance. But its symbol is not the same. Its symbol is this way. What does this symbol mean? This is the resistance. It means that instead of electric current to flow from point A to point B in a straight line, it will be flowing in a zigzag. That's what we say, that it limits the flow or reduces the flow of electric current. So this we call the pictorial representation. Because the pictorial representation is not relating sometimes with the physical appearance of the component. For instance, we have a schematic symbol of capacitor. This is the schematic symbol of what? Of capacitor. So, well, we know that the capacitor, the physical appearance of capacitor is not like this. But we know the fundamental function of capacitor is no charge. Right? So these are the parallel plates of the capacitor. So it means that this one will be storing positive charge and this one will be storing negative charge. So this we call it pictorial representation. And sometimes this a schematic symbol representing the operations of the component. Are we together? Yes. Are we together? Yes. Our friend there in charge. Oh. Oh, we say that electronic schematic Henrich is charged. Schematic symbol. Electronic schematic symbol is the graphical representation of the electrical or electronics component. It's a graphical, say graphical. So it's a graphical representation of what? So I wrote the representation twice. It's a graphical representation of the electrical or electronics component, where in the schematic circuit diagram. In the schematic circuit. So this is the graphical representation of electronics components in the schematic circuit diagram. And the meaning of what? Schematic symbol. So it's a schematic are our map to design, building, and troubleshoot electronics and communication circuits. So you say that electronics schematic symbol, electronic schematic symbol is the engineering. This is the engineering map. Engineering map, so we call it engineering map. This is the engineering map to design or to build, design or to build, and then troubleshooting. Troubleshooting the electronics and the communication circuits. So this sentence gives us an alert or the piece of information that you as the electronics technician, you are not only supposed to know this electronic schematic symbol in order to draw the schematic circuit diagram, but also you are responsible to know because it can help you to understand this schematic circuit diagram which has been drawn by other technicians or other engineers in electronics or electrical field. Okay? So once you understand, you can troubleshoot. Troubleshooting is fixing. It means that finding the problem and fixing it. Are we together? So we need to know these schematic symbols not only for drawing what, not only for drawing the schematic circuit diagram, but also we need to know this concept in order to be capable to troubleshoot electronic system or communication system which has been designed by other engineers and implemented effectively. Class, are we together?
Yes.
So he said this one. Understanding about how to draw, how to read, and follow schematic symbol, follow schematics is important. So this we call it is the important concept in all levels of what? Of electronics and the telecommunication engineering. So to understand about how to read, how to draw, and how to follow the schematic, this is the important concept for all levels of electronics and telecommunication engineering. So you have to understand this concept in order for you to enjoy the beauty of electronics. Then we say another key point before we go to those examples of the schematic circuit diagram. We say that in this module, we will cover fundamental concept about fundamental concepts about electronics, schematic symbols. So we'll be covering fundamental concept about electronics, schematic symbols. So fundamental concept means that basics. Any question up that point? Any question up that point? No question. The local students, they don't have. Did you understand? Yes. Eh? Yes, sir. So it is still simple. Okay, that is good. If you have understood, congratulate yourself that you have understood the introduction. If you have understood, congratulate yourself. So he said that if that's the case, he said that the following are some of the electronics schematic symbols. Electronic schematic symbols that we use a schematic circuit diagram. So the first is fundamental. So now we say that we are done with introduction. So you can have a small subtitle which we call electronics. Electronics, schematic symbols. Electronic schematic symbols. Electronic schematic symbols. So the fundamental electronics component, we call it resistor. Say resistor. Resistor. Say resistor. Resistor. So you say that the resistor has two electronics schematic symbols. Resistor has two electronic schematic symbols. These are the two schematic symbols. The first one is zigzag. So the first one is zigzag. And the second one, we may use a rectangle. The patriotic resistance. This is the first terminal, second terminal. First terminal, second terminal. Stop writing. Look on the blackboard. This symbol, we call it international. International schematic symbol. The international schematic symbol of a resistor. And this one, we call it US. US electronics schematic symbol. So this is the US notation, this is the United States notation, and the other ones we call it international notation. When you say that international notation, you will find the same symbol whether you learn electronics in India or in China or in Japan, wherever, by the means of international symbol. When you say US electronic schematic symbols, means that Americans are often use this symbol to show or represent resistance. So the questions comes now. Why do you see American and the international? Why should you not see that this is the schematic symbol of resistor for the South Africa? Okay. So the reason is, you have to remember, according to the history of electronics, the semiconductor devices have been discovered in electronics in US. And US is one of the countries that leading in electronics engineering. Okay? So you may either, so for we who are Tanzania, you may use this symbol to draw the symbol, the schematic symbol 40 of resistor, or you may use this. Are we together? Are we together?
Yes.
But we say that in case of resistor, we have two types of resistor. We have fixed resistor, and also we have variable resistor. So we say that the resistor has two, so it means that the fixed resistor, so I forgot here, the fixed resistor has two electroschematic symbols. Fixed resistor, it's a resistor which its resistance does not vary. You cannot vary its resistance. Students, listen. In electronics and electrical, we have two types of resistors. Okay? We have fixed. We have, if you categorize resistors, we have linear resistor and non-linear resistor. But just let me explain to you in the high architecture. We have fixed resistor, and also we have variable resistor. So the fixed resistor, it's a resistor which its resistance does not vary. You cannot vary its resistance. If its resistance is 240 ohm, then there's no way out. You can vary maybe from 0 to 240 ohm. So the thing that which you are going to experience, we have a simple resistor that when you use the circuit, it provides resistance of 240 ohm all the time. Are we together?
Yes.
Are we together?
Yes.
Let me repeat. For instance, you have a resistor or a fixed resistor of 200 of, let's say, 100 or 1 kilo ohm. 1 kilo ohm. If it is fixed, it means that you cannot change its resistance. Resistance always is either. It's always is 1 kilo ohm. 1 kilo? So it got to fix the resistance. So its resistance does not vary. Okay? But also we have what? Variable resistor. We can have a variable resistor of 1 kilo ohm. So with this variable resistor, you have a point or a junction, a terminal, where you can vary the resistance of the resistor from the minimum value to the maximum value, or from the maximum value to the minimum value. So for the fixed resistor, its resistance is always 1 kilo ohm. If you have a variable resistor, and then its resistance is 1 kilo ohm, it means you can change, you can vary resistance of that resistor from 0 to 1 kilo. So you can vary resistance, you can set resistance of this variable resistor to be 500 ohm. You can set it to be 600 ohm. You can set it to be 100 ohm. You can set it to be 50 ohm. You can set it to be what? 700 ohm. That is variable. Class A variable resistor.
Variable resistor.
So this is fixed resistor. So number 2, we say that variable resistor, or we call it potentiometer. Potentiometer. Variable resistor, or in other words, we call it a potentiometer. Say potentiometer. Say potentiometer. So he said that, let me just give you a clue. We say that a variable resistor or potentiometer, a variable resistor or potentiometer has 3 terminals. Has 3 what? Has 3 what? 3 terminals. So he said that the third terminal is used to vary. It's used to vary the resistance of the resistor from minimum to maximum value. So a potentiometer, or say potentiometer. Again, say potentiometer. Again. Ask your neighbor, do you like potentiometer? What did he or she say? She liked it. Ask him or her. In what extent? So the schematic symbol for the potentiometer, we have 2 symbols. So subwriting look on the blackboard. We have 2 symbols for the OT, for the variable resistor. This I say is subwriting, subdrawing. Zaina, I say. So this is terminal 1, this is terminal 2. Okay? Then the third terminal is this one. So this is terminal 3. Okay? Yes. Okay? Yes. Or we can have a 2-terminal resistor. 2-terminal resistor. And this is terminal 1 and this is terminal 2. And then we have an arrow. So this is terminal 3. Are you together? Yes. So this one we didn't label. This is figure 1. We call it the schematic symbols, in plural, schematic symbols of a resistor. Schematic symbols of what? Schematic symbols of what? Resistor. So these are the schematic symbols. So this is figure 2. Take your pencil. Electronics technicians should have a pencil all the time. The schematic symbol of a potentiometer, or what? Variable. So this is the second electronics components that you have to know and the learn its symbol. So whenever you find in any schematic circuit diagram, you know that this is potential. Whenever you find this symbol, this is potential. First terminal, second terminal, or first terminal, second terminal, and this is the same terminal. Are we together, class?
Yes, sir.
Then number 3. Number 3, let us learn the schematic symbol of capacitor. The schematic symbol of fixed capacitor. However, that we don't have variable capacitor. Let's say that we have fixed capacitor. So he said that a capacitor has only 2 terminals. Just only 2 terminals. Just only 2. So we have also 2 schematic symbols of capacitor. So writing in electrical engineering or in electronics, you have different types of capacitors. Okay? Huh?
Yes.
Huh? We say that we have learned that we have paper capacitor. You remember that?
Yes.
You have learned about Jyoti? Huh? Nika capacitor. You have learned about Jyoti? Electrolytic capacitor. You have learned about Jyoti? Ceramic capacitor. So simply, we can categorize those 4 types of capacitors according to the dielectric material into 2 main groups. The first group, we call them non-polarized capacitor. Say non-polarized capacitor.
Non-polarized capacitor.
And the second group, we call them polarized capacitor. Say polarized capacitor. Polarized capacitors are the capacitors which have positive terminals and negative terminals. In other words, polarized capacitor, we call them electrolytic capacitors. Non-polarized capacitors are all the capacitors which do not have electrolyte or which do not have positive and negative terminals. So it means that mica capacitor is non-polarized. Ceramic capacitor is non-polarized. The other one is what? Paper capacitor is what? Non. Those are the categories of capacitors according to the dielectric material used during the manufacturing of that capacitor. Are we together?
Yes.
Are we together?
Yes.
Eh?
Yes.
So he said that in electronics, right quickly, and electric, we have electrical engineering or electrical science. We have 2 categories of capacitors, and we name them in this way. Ask your neighbor, do you enjoy the workshop of electronic schematic symbol? Ask your neighbor. If you have any question, our friends up here. What did he or she say? Undefined it. Okay. So the first one, we call it polarized capacitor. Polarized what? Polarized what? Polarized what, engineers? Capacitor. In other words, these polarized capacitor, we call them electrolytic capacitor. The second one, we call it non-polarized. Non-polarized what? Non-polarized what? So polarized capacitor, this we call it electrolytic what? So non-polarized capacitors, sometimes we call them as the general name that ceramic capacitor. Ceramic what? Ceramic capacitors, and we have it. So now the schematic symbol. The schematic symbol for polarized capacitor is this one. It's a little bit different because for you just know the schematic symbol for a capacitor without it taking care whether it's electrolytic or non-electrolytic. You just know the symbol for it. So from now onwards, because you are going to use electronics, it's better to know the symbol for polarized capacitor and the schematic symbol for non-polarized capacitor. Sikilizeni na mwangalie. So here, this is the negative plate and this is the positive plate. Okay? Yes. This is very important because if you'll be using the electrolytic capacitor, this is the schematic symbol that you have to use in your drawing, and this is the schematic symbol that you have to use in simulation. That's why I told you that this topic of electronic schematic symbols go parallel, or actually it accompany the topic of simulation. Because the library of electronic components is represented by using the electronic schematic symbols. So if you don't know the schematic symbol of the components in simulation, it's difficult for you to find it and to use it. Okay? Okay?
Yes.
Then here is the schematic symbol of what? Polarized duty. Polarized duty. Non-polarized duty. Zaina. Today is today. And the other guy who is sitting on the right hand side, I see you sending signal. So this we call it figure 3. The schematic schematic symbol. I know that you might think that the concept that I'm teaching you, you know them, or you know them, and you might take it easy. But I want to tell you, my dear student, this concept is not easy the way that you think, because we have so many schematic symbols of electronics components. When you be learning about electronic science or electrical science, we didn't care whether it's electrolytic or it's not non-electrolytic. But now, because this is the area of your specialization, it's better to know different symbols. Because even these symbols are the ones that you are going to find drawn on the PCB board of most of electronics components or most of electronic system or products. Are we together?
Yes.
Are we together, class?
Yes.
Then another, or the first fundamental or basic electronics components or electrical components, we call it inductor or inductors. Say inductors.
Inductors.
Say inductors.
Inductors.
Ask your neighbor what the meaning of inductor. So we are not defining the meaning of inductor. So you say that inductor. You say inductor. Let me just tell you what is inductor, because I know this might be new for most of you. You forgot it. Inductor, we say that in the passive electrical, keep quiet. Tell your neighbor, keep quiet.
Keep quiet.
Is a passive electrical component that is used to store magnetic or electric energy. Use it to store magnetic or electrical electrical charge. This is storing what? Energy. And if you do remember, for we who have enjoyed advanced electrical science, we know that the formula for calculating that energy, we will say a half times 20 self-inductance of the coil times current square. For we who have got a chance to enjoy the beauty of advancing electrical science. Then in case of the capacitors, because engineers, you have to understand where we apply these formulas. We didn't learn them for leisure. They have application. The challenge is you just learn the stuff, then you forget. You go to the next level. You expect the miracles. Tell your neighbor, I'm very sorry to see that you have forgotten the previous materials. Tell your neighbor. You don't tell your neighbor. The formula, what is capacitor? Capacitor is electronics or electrical, or we say that capacitor is electronics or electrical passive component, which is used to store electric charge. And then that the formula to calculate that electric charge, we say it is what? Pardon? So electric charge. So we say that it is stored electric charge in form of electric energy. So this electric energy is equal to half times 30 capacitance, then quantity of charge squared. If you love electronics, there is a relationship between these components. This is the self-inductance of the coil, and this is the capacitance of the capacitor. This is the current, electric current flow is through the inductor. This is the quantity of charge stored by the capacitor. This is the electric energy. This is the electric energy. This is the constant half. This is the constant half. I used to tell you, and I'd like to tell you once again, electronics engineering is beautiful. Tell your name. Especially if you love mathematics. So these two formulas are not a part of the subject. I've just reminded you for those who have got a chance to learn those stuff. And if you stay connected this year, I'm going to reveal the relationship between electrical science or electronic science and electronics engineering. I'm going to reveal why were you calculating, where do you use all of those calculations that you've been doing to calculate the power, to calculate electric energy, to calculate quantity of charge. Quantity of charge is equal to what? Number of electrons and sort electronic charge. You forgot. Quantity of charge also is equal to what? Electric current times time. Form 2. Tell your neighbor. This is all about static electricity. Form 2. Tell your neighbor that is Form 2. And it was the first topic. So if you forgot the first topic, how about the fifth topic? Kama umesahau tu mada ya kwanza ya Form 2. Sasa ya tano unakumbuka. Ukumbuki sasa hivi unasema wewe ni mkubwa, kwa hiyo ni kazi ya wadogo sana. Sikia? Okay, that is good. Are you ready for the symbol?
Yeah.
So he said that the inductor has two terminals. The inductor has two terminals. Then you say again, the inductor has two schematic symbols. We have the US schematic symbol, and also we have the international schematic symbol of an inductor. Stop drawing, look on the blackboard. Stop drawing! Look and listen. The first schematic symbol in US, or we who would like to use the schematic symbol of US, We draw inductor by using this symbol. For we who are American. Okay?
Yes.
Or American also draw the schematic symbol of inductor by using this symbol. Possibly you have met them, but you have never think about that. And because now you say that electronics engineering and telecommunication engineering, I love you so much. So this is terminal 1, this is terminal 2. This is terminal 1, this is terminal 2. So this we call it figure. So this we call it figure what? Figure 4. Figure 1. And this one we call the US schematic. This is not us, this is US. Because somebody I heard from my heart that what is telling me. There is a student who has written what? Us. Instead of what? US. So U is capital letter and S is capital. Okay, the US schematic symbol. The US schematic symbol 40 of inductor. Sometimes you can find that engineers call these components as a chalk. Sometimes. Say chalk. Not chalk like this. Then, but internationally, we draw inductor by using this symbol. It's new for you. I say stop drawing, look on the black. Otherwise, you will get lost immediately. Huh? This is terminal 1, this is terminal 2. I say it stop writing. Stop right. Gardner. So we had another symbol of resistor, which is international. You remember? So what the difference between the symbol, the international symbol, the international schematic symbol of resistor, and the international schematic symbol of inductor? Here's the difference. For inductor, we have to shade the rectangle. We have to shade what? The rectangle. So the rectangle is shaded. So this one, we call it figure. So this we call it figure 4A. This is figure 4B. And we call it the international schematic symbol. Schematic symbol of 40 of inductor. The schematic or the international schematic symbol of inductor. Are we together?
Yes.
Ask your neighbor, did you draw inductor on that day or just one? What did he or she say? You have a question? You're welcome. Speak loudly, just like how I speak. I speak loudly in such a way that people outside hear my voice, not only in this class. Speak loudly. Speak English. Why inductor is called the reactance? I want to take the answer of that question. Gardner, did you hear the question? No, Gardner did not hear your question. Repeat. Because Gardner was not in the class.
Why inductance is sometimes called an reactance?
Why inductor is sometimes called an inductance? Reactance. Why? Zaina, can you try? Muhammad, can you try? Isa, just brief. Can you try? Brief, just one sentence. Okay, thank you. Thank you very much. I know Isa, where are you heading to? So let me bring you back to the class. Good job. So, the answer of that equation, say, our country still have a great job to do, especially in teaching. Listen, students, listen. If you wanted to understand electronics, you have firstly to understand how resistor works. Every type of resistor, how does it work? The second component is capacitor. The third component is inductor. The fourth component is diode. The fifth component is transistor. Because the complicated electronics components such as integrated circuits is just a combination of resistor, of capacitor, of diode, of transistor. So, and you have to learn them in discrete level. Say discrete level. Yes. You have to learn them as individual components first. For instance, if you allow electric current to flow through this polarized capacitor, what happens? If you allow, for instance, electric currents of 2 amperes to enter this terminal 1 of this capacitor to terminal 2, what will really happen about the current? If you allow the voltage of 2 volts to enter through this capacitor, electric capacitor, what am I going to receive? Okay? Okay? If example is applying the power of 1 watt, what will be happens on the next part? So you have to learn them as individual component first. That's what we call the electronics discrete level. Are we together? Yes. So I told you and I'd like to tell you, if you don't know what is resistor and how does it function, you don't know what is capacitor practically and how does it function, you don't know what is inductor and how does it function, I want to tell you that you still know anything about electronics. So now let's answer the question. The fundamental passive electronics components are 3: resistor, capacitor, inductor. If you understand them, you are extra miles in electronics. I want to tell you that. Okay? Okay? So listen. Resistor is not a resistance. Let me answer that question in this way. This is the symbol for resistor, right? Huh?
Yes.
And then the property that has its quality resistance. So you agree with me that resistor is not equal to resistance. Do you agree?
Yes.
Huh?
Yes.
Yeah. So why it's not equal? Why these are the different terminology? Resistor, it's a component. Resistance, it's electrical property of resistor. Can I repeat? Can I repeat?
Yes.
Resistor is a electronic component. You can take a note. These are expensive, and I call them. These are special materials that I'm providing to you. You can take a note. Let me repeat. Resistor is an electronics component. It's a component. It's physical. It's a component which is physical. Okay? Resistance is a property. Angalia kule jamaa na chati. Nashika kabisa hata hana tabani. Nipigie kofi jamaa. Anaangalia nyuma. Resistor, it's a component. That is bongo. That is bongo. Bongo leg, and that is bongo pitch. Yani unatema nondo. Yeye mwanzako hana hata habari, yani kwanza anaangalia. Hiyo ndo bongo ni. Wengine waambia haya, angalia mbele. Mwanzako anaangalia nyuma. Sasa mimi naangalia nyuma. Okay, let us continue. So resistor is what? Okay? And in resistance is a property of a resistor. So resistor is a component which limits electric current. Resistance is a property that limiting the flow of electric current through it. So resistance is a property. Resistance we don't find only in resistors. We have different materials which have resistance. And when I will teach you later on about the sensors, most sensors they are just using these 3 properties: resistance, capacitance, and reactance. Halo. Acheni kukalini. Acheni. So this is the property. Then we have another component which is called capacitor. Okay? Yeah? Its name is called what? This is what? Component. But capacitor is not equal to his. The word capacitor is not equal with the word capacitance. Capacitance is a property found in capacitors to store electric charge. If a capacitor does not have capacitance, it cannot store electric charge. If a resistor does not have resistance, it cannot limit the flow of electric current. Simple like that. Sasa nyinyi mnasoma bila ufundi gani? Ask your name. For 10 weeks, which kinds of the technical skills in the course have you been having? Those are the fundamentals. You have learned this in Form 1 to Form 4. So somebody is telling me, I'm sorry, remember we are in Bongo. We are in Bongo. Yes. We are also teachers who are teaching students are not interested with the subject, or are not interested with teaching. So they find that teaching is punishment for them. Haya mtasoma basi mtawapa maswali. Wewe uliambiwa wewe mwalimu kwamba utasoma afu utapewa maswali. Then we come to the new. This is what he called what? Inductor. Inductor is not equal to reactance. We have inductor is not equal to inductance. It's not equal to what? Inductor is an electrical component. This is the component. Inductance is a property. It's what? It's a property. So I'm answering your question why inductance is called reactance. So I want to answer it technically. So here we say that we have resistance, right? And we have told you that the reciprocal of resistance is called resistivity. We agree? Huh?
Yes.
Then we told you that the reciprocal of resistivity is called conductivity. Let us stop with formulas. I told you engineering is all about numbers, formulas, diagrams, tables, and what? Graphs. So ask your neighbor, how far are you now with those 5 components of engineering? You are good in what? Diagrams, eh? Yes. But you fail to draw the diagrams in test 1. Or you just fail that one. Yes. But the others you can pass. Okay. Then, also, in case of the inductor, the reciprocal of inductance, because inductance is L, resistance we use R, capacitance we use capital C, inductance we use L. Okay? So the reciprocal of inductance is what we call reactive. Okay? Okay? So if this is the case, you agree with me that resistor is not equal with the resistance. We have already agreed with this. Yes. And resistance is not equal to resistivity. You agree with me? Yes. And resistivity is not equal to conductivity. You agree with me? Yes. Similar. Inductor, we agree that is not equal to inductance. Okay? And also inductance is not equal to what? Reactance. Simply so we can say that inductor is not reactance. Why? Because reactance is electrical property. While inductor is electronic component or it's electrical component. Did you understand? Did you understand? Sometimes if you don't know the difference between these terminologies, you can confuse them. Okay? You can? Ask your question now, sir. Can I claim the other part? This is an extra materials. I didn't plan to teach you because I love you. That's why I have provided this one. These materials are expensive and they are not found easily because you have to find them by reading different sources and then you come up with a summary. Okay? If you want it to realize, they've learned about these three components since from 1 up to form 4, but you don't know the difference. Why? Because you have first focus. Learn the materials that help you to pass an exam. That is your only problem. You know what's your problem so that you don't understand this stuff? Because since the fundamental level, you are learning for the purpose of answering and passing what? Exam. Are we together? Your first priority is not to understand. Your first priority is to pass exam. So if your first priority is to pass exam, I want to tell you that forget about knowledge, understanding, and wisdom. Because knowledge, understanding, and wisdom is a process. But having material to pass the exam, it's not a process. You just review the past papers, the previous question, then you get the idea. Definitions appearing. Okay, let me command you see what is definition. What is capacity? What is capacity? What is capacity? Capacity is the what? Electronic component, which is to store what? To store members or orange, to store charge. You don't take time to think about that sentence. You just claim. If you be asking right, you are done. But you don't take time. How does it store charge? You don't take time because you have to take time to think. How does it store charge? Okay? So because in your exam, they don't ask you that how does it store charge, they just ask you to define capacity. And to define capacity is simple rather than to know how does it store charge. Class, are we together? Yes. Okay, the entire class stand up. Stand up quickly. Stretch yourself. Have your seat. Okay, another electronics components that we have, we call them switches. I'm about to end the class, don't worry about that. I'm about to end the OT. I know that you don't want the class of today to end, but we have to end because of time and because that you're tired. But if I could be you, I could say, continue. Number what? Number 1. Number 5. Ask it quickly. This is not a part of the subject. I've just answered or I've just given you material according to the question. Don't ask me to go into too much detail because I need more than 3 hours to tell you the secret there. So I've tried to summarize. This is not all. Pardon? The answer of this question, inductance, not reactance. What? Inductor is neither resistor, neither inductance. It's called what? Resistance. The question was why inductance is called reactance. That's the question. Okay? So the answer is inductance is not a reactance, inductance is not a resistor, inductance is not a resistance. Inductor is inductor. Number 5. We have electronics components that we call them electrical switches. Electrical switches. In short, we call them switches. Class A electrical switches.
Electrical switches.
This is mechanical switch. Okay, you can call it electrical because it is switching electric power. That's mechanical. Mechanical switch. So electrical switch, say electrical switches.
Electrical switches.
Again?
Electrical switches.
So he said that. So the electrical switch is actually to turn on or to allow or block electric current to flow from one point to another point. That's the function of the switch. To allow or not allow electric current to flow from one point to another. So, it's fundamental question. Tusaidiane mangoja tusaidiane. Tusaidiane kwa sababu wewe una hatari sana. Semisa inaishi yani vitu vya msingi bado hujavinasa. Kila sasa ndio wewe mwalimu wetu tufundishe. Ninafundisha vya kwangu. Wengine mwadai na wafundishe vya kwao. Unasema over na huyu lecturer atatufundisha. What is electrical switches? Say electrical switches.
Electrical switches.
Say electrical switches.
Electrical switches.
Simply say that is electrical component which allow or not allow the electric current to flow from one point to another point. From one point to another point. So he said that in electrical and electronics engineering, in electrical and the electrical or electronics or telecommunication, the electrical switches exist in many different forms. Many different forms. We have different forms of electrical switches. And these electric switches, we are using them in electronics, in electrical, in computer, in telecommunication engineering, and also in mechatronics engineering, in biomedical engineering. So when you hear something which is just many different forms, you have to be attention. It means we have different types of electrical switches. Okay? So I will teach you series of these switches because you'll find them. And if now you refer, you attend schematic circuit diagram, you know that you drew while some other schematic symbol you don't know what to say. But from today, go and review. You will start understanding what you've been drawing or what you've been copying from internet to the A3 what? And then submit it to who? Submit it to who? To Olenjolai. In order to mark it. And be humble. And show love for his students. Okay. So he said that the following are the few or are the following are some electronics schematic symbols. Schematic symbols of electric. We call it electric, or sometimes we call them just we call them switches. We call them electric, or sometimes we call them switches. We call it electric switch, or sometimes we call it a switch. Okay? Okay, Enrich? I say we call it either electrical switch or switch. If you hear electrical switch, have the same meaning with the switch. Okay? So the first one, this one we call it it's a basic issue. We call it single pole, single throw. Single pole or single pole or single throw. In short, in electronics and electrical, we call it SP. Let's say single pole, single throw. That is not the voice of my students. Class, speaking healthy. Say single pole, single throw. Again, if you pronounce it, you keep in your mind. You keep in your mind? If you don't pronounce, you will forget it. Once you close the exercise book, you forgot. And it will be difficult for you to remember it again. Unless you do fire extinguisher. You know fire extinguisher? Yes. Trying your level best to spend the same night, the single night, to review all the materials. That's called the single. That's called the fire. Fire. But I don't know which class of the fire extinguisher you use. Class A, class B, or class C. Okay. Again, class A, single pole, single throw. Single pole, single throw. Single pole, single throw. Again.
Single pole, single throw. Single pole, single throw. Single pole, single throw. Single pole, single throw.
Loudly.
Single pole, single throw. Single pole, single throw. Single pole, single throw. Single pole, single throw.
So single pole, in short, we call it SPST. Sorry. SPST. This is the abbreviations of single pole, single throw. Tell your neighbor, do you hear good news of electronics? So it's like the SPST switch is the basic electrical switch which has only two terminals. Which has only two terminals. So let me draw the schematic symbol of that single throw or single pole, single throw. So this is, we call it 5.1. So the schematic symbol of single throw, single pole, is the one that we use to draw in our schematic circuit diagram. Single pole, single pole, single. Look. This is what we call the pole. So it is only one. And then when we close the switch, it means we throw this pole into here. When you close the switch, we throw these poles into here. So we have a single pole and we have a single what? Are we together, class?
Yes.
This is figure 1, eh? Yes, according to you it is figure 1. But according for us, this is figure 5. Schematic symbol of single pole, single pole. Then 4, 5.2, the second type of the switch. The second one, we call it single pole. Say single pole.
Single pole.
Then we have double throw. Say single pole, double throw.
Single pole.
This abbreviation is SPD. Single pole, double, plus single pole, double throw.
Single pole, double throw.
Single pole, double throw.
Single pole, double throw.
Again, so sing the song, single pole, double throw. Single pole, double throw.
Double throw. Single pole, 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 double throw.
Thank you. Congratulate yourself. You sang it very good. Congratulate yourself. The single pole double throw in the switch is the switch which has single, but it can be thrown to other terminals. Other what? So he said that basically he said that he has three terminals. It has three terminals. So let us draw. So growing so brightly. I say so growing so brightly. So I think that do some correction here. This is the symbol. So put those small circles. So here, this is what we call the single pole.
Yes.
Single?
Single.
And then this one is equal to the first throw. The first, and here we have another throw. So this we call what?
Single pole.
Eh?
Single pole.
This the first thing,
Double.
and this one? Yes, that's the point. So this is figure 5B. So this is 5A. Huh? Schematic symbol of what? Single what? So let us conclude with the last types of the switch, which we call the double pole, double throw, and then we will end our class. And I know that for the local students will be extremely happy. I don't know that they will be extremely happy because they understood today's lecture more than other lectures, or maybe they are happy because it is time to sing our wonderful song that we used to sing in kindergarten, primary school, that we call sasa sasa saya kwenda kwetu, sasa sasa saya kwenda kwetu, mwalimu mwalimu tutaonana. Very good. That is what we call it. Swahili. By media. Yes, we used to sing that song when we are living in the school. Sa, sa, sa. So it has only a chorus. Sa, 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 ya kwenda kwetu. Sa, 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 ya kwenda kwetu. Kwaheri mwalimu, tutaonana kesho. During that time when we were singing that song, we didn't have stress of marks, or stress of all. We don't know even how to write number one. That was not our mistake. But also we are not thinking about what are we going to eat today, or what we are going to wear. What actually we are thinking to leave the school and go and try to find the new gets. Okay? To interact with other kids. That's what we are thinking all the time. You don't bother about what to eat, what to wear, where to sleep. That's the business of your father and what? And that's why the word of God says that anybody who looks like a young or a baby or a child will see the kingdom of heaven. Why? The child does not have stress. Ask your neighbor, how many stresses do you have now? Eh? Ask your neighbor, how many stresses do you have now? So tell him, because you have stress, that's why we are singing a interesting song to remind you that stress is part of life. The double pole, double throw, we say that is a electrical switch. I'm about to end the class, don't worry. So get prepared to sing that song, right? Will you see it? Yes. So it's electrical component. Electrical component which has two poles and the two throws. It has one, two, three, four, five, six. It has 6 terminals. It has 6 terminals. It has 6 terminals. And here it is schematic. So writing. Here it is schematic. Here it is schematic. So do you see figurative class? The schematic quality? 40? Double? And if that the case, this is the end of our class. Lecture 1 about electronic schematic symbol or introductions and electronic schematic symbols. So while you are drawing, let me just say some few words for the online students. Online students, this is the end of our first lecture or workshop about introductions of electronic schematic symbols. So make sure that you review this material, you draw the diagrams by using the pencil, and you draw while you are writing in your mind, or you're writing a mind, and make sure that you'll be interacting with different schematic circuit diagram, which has I say to students, make sure that you finish to write what you have written on the blackboard. Some local students here have the target to take photo. No. Why should you not take a photo while you are here? You will be hurrying to go somewhere, but I want to tell you that you might find that the place where you are going, you might not even do anything. You could say it's better if I could stay there. Okay? That's how life it is. So go through these materials. In case you have any questions, don't hesitate to ask in the comments. I want it also to promise you that get connected, because lecture 2 or session 2 or the second class of the electron schematic symbols will be on air, or will be ahead, or will be next after this class within a short moment of time. So make sure that you subscribe onto our channel in order to receive notifications whenever we publish any electronics and telecommunication engineering content to help you to learn and enjoy electronics engineering for the rest of your life. So if that's the case, in case that you have any question, don't hesitate to ask in the comments and interact with other students. But another thing, that make sure that you have some questions, because if you don't ask the questions, it means you didn't understand. So if that's the case, thank you very much for the local students. Before I would like to end this class or this lecture in a very unique style, right? Yes. I have some local students who are kind of being tired for sitting for a long time. So we want just to say goodbye to the online community this time. So we are going to sing a very fantastic and non-stress song of Bible. Right? Are you ready, class? Okay, so now let you get prepared, so we count 1 up to 3, then we'll sing. First of all, let us congratulate. Did you understand? Yes. Did you understand? Yes. Sure? Yes. Okay, so let's go ahead and congratulate yourself. Wait. Okay, so we are going to sing our song. Are you ready for that? Yes. Huh? Yes. Remember, when we are singing this song, it does not mean that we are children. No, we just remember that time. Sometimes it's difficult to have it again in our life, because we are getting older and older and older, and the stress are always on the way. So 1, 2, 3. So let us 1, 2, 3. Sa 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 ya kwenda kwetu. Sa 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 sa. You are not singing. Sa 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 ya kwenda kwetu. Now make it no sa 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 ya kwenda kwetu. Mwalimu tutaonana kesho. Again, last thing. Sa 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 ya kwenda. Thank you very much. May God bless you.